Hello and welcome back to my CATIA V5 tutorial series. Today we're going to talk about user-defined features and how we can save them to a catalog like this one. As you can see here, I have this feature that I created previously. It's called a thread. This allows me to very easily put threads on cylinders like so. I can use this feature anytime I want with just 2 clicks and I can have my thread. You do need to set the parameters right here in the tree, because this works with multiple values. You can put the feature on and then you can change the thread size and pitch. The original diameter doesn't even need to be the correct size. It'll just cut it to the right diameter. You can also go back and change the length of these very easily, like so. A bit of a wait time. You can add another thread to the other side. You do though need to put chamfer on it before, and that is no problem for this feature to work. It works fine even like this. And like I said before, you can actually choose any size you want that is smaller than the original diameter. This one actually it's supposed to be 5, but you can actually use a 3 mil like this and change it to 0.5 pitch. And as you can see, it will cut itself, no problem. Now let's teach you how to do this and more. Okay, now what are UDF features? Well, UDF features, or user-defined features, are a collection of operation and elements that you bundle up very nicely into one single element like this. Then you can then instantiate, which is basically just a copy with a change of input that you can then use anywhere around your part, just like this. Now, I said anywhere around your part. That is true, but then you can also add this feature to your catalog. So you can find it here and use it however you want on any parts. But that, however, requires you to save your part to your hard drive and afterwards save this UDF feature to a new catalog or to an existing one if you like. And then you will be able to use it anywhere on any part. This is usually how a part that stores an UDF feature looks like. You have the base, the surface that you applied on, which is this pad. Let me just get rid of that. Then you have the feature itself applied on something, which is the remove one in our case here, and you have the construction of that feature here. And what you do is take this along with the construction that defines it, the geometrical set that defines it. It doesn't have to be a geoset, it can be just a simple body, but in my case I needed it to be a geoset. And then you insert knowledge template user feature, and it will create this, maybe you're more familiar with this symbol here, and it will create a user feature here, which you can then save it to a catalog. But first you need to save this to your hard drive. Okay, so let's start doing our very own first UDF. Good. So, like I showed you before, you start with basically the geometry that you want to put it on, to have like an input. So for us, it's gonna be a cylinder. Create a cylinder like this. Diameter, let's say 10. Part design, I use part design because this is what generally 3D printed stuff should look like. It should be solid. The thread I'll be using for 3D printed parts. That's pretty much the only use I could find. This is the input. Now you create another geoset. You can put something inside here and call it input. And the input will be the 2 surfaces actually. It's not going to be the solid, it's going to be the 2 faces, this one and this one. And we extract them here. This one, and this one. You can make this a different color just so you know, and you can call it front face, and this one you can call it side face. And here you will go create another set, call it construction or whatever. This one you can call it UDF. Part name you can call it UDF thread. This is input. This doesn't really need to be here. It could have been underneath the body, but no. Right. And you can change this to a different color. Now you go ahead and hide the part, and you go ahead and hide the input, and you need to go ahead and hide these planes. And this is the only geometry you need to use to create your part, and it needs to be adaptable. That's the main trick. You have these two surfaces, and from these surfaces we need to create our thread. So basically what you do is design a thread. First, I guess you need a plane. You need this plane actually, but you cannot use this because this is connected to this part, and it's not actually an input. You need to generate this plane, this exact plane, using this geometry, the one that you extracted. And we're going to show you how to do that. First, you have a cylinder, which is quite useful because you can create an axis from that cylinder. Good. From this axis, you can use this axis to intersect this, and then you create a point. Intersection, axis, point. Good. You have an axis, then you need another point actually, because from a line and a point you can create a plane. How do we create this plane? Let's see. I guess you create another plane here. No, let's go back a little bit. What you need is a point here. To do this, you will extract the boundary of this. Where is it? Should be here. Boundary. Extract the boundary of this face, and then you have a circle. Now on this circle you put a point at the start of the curve, because you don't actually need it to be this plane. It can be anywhere actually. So wherever this point ends up, you will use that as the good plane, because it doesn't really matter since our thread will be cylindrical. Good. Now you have this point. Now you will need to create a line from here to here. Good. You have one line. Lines are directional, that's important, just so you know. So this line starts from here and ends here, not the other way around, even though geometry should look exactly the same, but it's important. You're gonna find out in a few minutes. For example, now I need another point here in this direction, or maybe a line to create the other axis. But let me show you why this is important. Click this point. Let's say 10 millimeters in this direction. Maybe 10 is too much. Let's go 5. And we have this point here, and this point is inside here, and we're gonna generate our thread all the way around like this, and it should be fine. But let me show you something. This works, but if you have the cylinder in the other direction, let's say from here to here, let's reverse it, your point will be outside, and that's not good, because then it means you cannot use your feature everywhere. You will just be able to use it sometimes, but we don't want to use it sometimes, we want to use it all the time. And then we go back. And we're gonna do a little trick here, which is very useful. I hope you remember this. This is like a trick to remember all on its own. It has nothing to do with UDFs, but you take this surface here, this front face, and then you offset it. Ah, there it is. So you offset this, let's say 1 millimeter in this direction, and then you copy paste it, and then you reverse the direction. You join the two offsets, you check connexity, click OK, then you have like a double element. Now you use the near command, you select this joint that you just did, and reference element, you select your side face, click OK, and now you are sure that this surface is going to be on the inside. Then you intersect this to this and click OK. And now you have a point on the inside every time. See? I reverse this like that. My point is still on the inside, the one I did stays on the outside. Switch to the outside. Alright, now we need to talk a little bit about parameters. We will add some parameters now. This one. So we're mainly going to be using length. 1, 2, 3. We're going to call this M, which is going to be, I don't know, the metric thread. It's going to be like the main diameter. We're going to need the pitch 1.5, and we're going to need the length thread length. Let's start with 20. And we're gonna need another parameter actually, and this is the H. We're gonna see a little bit later. This is actually, and we need the parameters here under the construction set. And now we're gonna use a point on this line. We're gonna edit the formula. We're gonna put the, where is it, metric divided by 2 because it's the radius, and we're gonna use this point as the point moving forward. So we're not gonna use this one. Where's the previous one? This one. We're not gonna use this one because this one is on the surface on the extract, but the extract might not be 10 millimeters. We want to use the one that's exactly 10 millimeters. Good. And we're gonna copy paste this. And I think I'm gonna create a new one as well. Plus 5 millimeters. And I'm gonna show you a little bit why we did this. Okay. We can create an axis system here. This is gonna help a lot. But first, I need to create a line here between this and this. Maybe make it a little longer. And this is the axis we're gonna use from now on, because, like I said, lines are directional, and this one has a direction from this point to this one. So it's gonna keep its direction anywhere this this surface might end up. It's gonna have the right orientation. So now we create an axis. We can put the Z to this, and we can put the X to this, and that's perfect. Okay, now we need to just simply create a sketch. It needs to be a position sketch. So it's going to be positioned on this plane. It's going to be projection point this point here, this intersect will be the middle point, and your orientation is parallel to line, parallel to this one. Good. Okay. We are going to create our thread profile, which is going to be something like this. We're going to add dimensions in a bit. Actually, I wanted to create this point here, so we need to start this thread a little bit outside our zone here, because if we start it here, then it'll just be a cutout in the middle, and it's not gonna look great. So we put another point here. We want to move this point somewhere around here, and we do that by creating another point with coordinates. But axis system is going to be this one, the new axis system, and it's going to be -1 millimeter. But actually we're gonna edit this, and it's going to be exactly the pitch, and you multiply it by -1. And the origin is this. Now, threads. We need to heavily parameterize this sketch now. We said we have this H here, and this H here, you need to look it up somewhere. It's actually this H is related to the pitch, and it's like this: 0.86603 times the pitch, 1.299 for this. And now we have the H. Then you can go inside, and you can find these definitions online. It's very easy to do. Any site, you can get pictures and draw this for yourself. But let me draw it for now. I'm gonna put a line here to mark the pitch, the thread diameter, the nominal diameter, that is, which is the M divided by 2. And with regard to this diameter, we can put the other dimensions. The bottom one is like this. It's supposed to be 3 divided by 8. No, sorry, 5 divided by 8 times H. Good. This is 60 degrees. You have a line like this, and this needs to go through this point, but actually, just to avoid any issues, I'm going to project this point like that. Coincidence. And then I'm going to allow for symmetry line like this. This length here is related to the pitch as well, and it's the pitch divided by 4. And actually that's all I need. What I need to do is constrain this to this, and this one I'm actually going to put H divided by 10. Maybe more, because I actually needed to be just a little bit off this, maybe not even at all. It could actually be 0, but I prefer it like that, just to be sure. Alright, now I need a helix. My helix should be here. I will select this. The axis is this one. The pitch, I will use the pitch of my thread. The height, I will use the thread length. That's done. Here actually I want this point, from this point I want to go like a straight line, like this, to be able to exit this this thread here and this cylinder and do the cut smoothly. So what I will do is not pick this point like that, because then I might end up in an issue where it doesn't know what point to take. It might end up taking the other end. So what I want to do is take an extreme. I select this. Direction is the Z direction, this Z direction, and then I get this point. Now I will select this and create a line, tangent curve like this. That's fine. Alright, now I need a support for this, and this surface might not actually provide the support I need. So actually I'm gonna create another cylinder here, because you can see our sketch will start here. And if I use this as a support surface, this part here will be unsupported and it'll give an error. So what I need to do is to create a point here with diameter of the size of the nominal thread diameter, and use this as a direction, maybe 500, and this one 20, I don't know, doesn't really matter. Okay, now for our output I need to create this body. But first, let's check something else. We wanted this to work even if this diameter is larger than 10 millimeters, than the diameter of the thread. So I'm gonna change this to 12 and see how it looks like. So our thread will be the size of our nominal size, but then we need to cut the extra bit away. So how do we do that? I assume we're gonna create another sketch. So maybe I'll just copy this because it needs to be done the same way, and delete everything in it afterwards, like that. And then I will project these points, this one and this one, as construction. That's fine. Now I will create a rectangle. Make sure this is here, and then this length here needs to be our thread length plus the pitch, maybe something like that. Yeah, that's way too much. I guess it's the pitch divided by 2. Did that work? Yeah, it works. Alright, good. So we'll just use this to cut around our screw. What I like to do now is go to part design and generate this as a solid, and then remove it afterwards with the Boolean operation, that's generally better to do. So I just do a rib. Here, not keep angle, I need to select the reference surface and our newly created reference surface. Good. I then maybe need to create a pad. Oh, sorry, forgot about this actually. Here I actually needed the profile here, and in order to do that I will hide this and go back to my helix and this, and I will actually create the sweep. With default surface like that. And I created the sweep in the wrong set. Right, so I'll create the sweep like this. Like that. Done. This pitch here I will then get a boundary. It's a multiple element, so I need to select near, and it's gonna be near this point here. Good. Now I can go back to part design. Get in my body too. I don't really like this. I want it to be here. So what I do actually is choose rib instead. Like that. Okay. Now the big cutout, I will do a shaft around this. There we go. Now I go back to the part body, define a work object, and I do a remove operation. Remove. Select this, select OK. That's it. Go ahead and hide this. You can change the color of this if you want. And update. Alright, now to do a simple check, we will reverse direction. Good. We will change this plane. That looks good. And we will change it again. Yep, that pretty much holds up. Let's set it to the initial position. That pretty much holds up. Now, to create the user-defined feature, what you would need to do now is this. Go to Insert, Knowledge Template, User Feature. You select the remove and control-click the UDF tree. And you put in a name here, like awesome thread design. You can keep this icon if you want. I just generally prefer to keep it different by choosing a different one. Click OK. Update. You need to right click and local update. Good. Now what you can do now is right click, instantiate, and then you'll be able to just click the surfaces and create a thread. But you notice you don't have anything underneath, so you cannot change the size. What you can do to change the size is this. Go to parameters, and then you look for the parameters that we created. bit of a mess here. It's not really clear to see, but you can actually expose any parameter you want from this menu. So you have the M, pitch, thread length, and the H you don't need because that's calculated. Click OK. This one doesn't actually update. You probably need to create it again. Right click, or you can actually double click to instantiate it. No, you can't. Instantiate. And now you have access to the parameters as well. You can change this to 8. You can change the pitch to whatever you want. Not negative, I assume. Right. In my original one that I showed you before, I had a list here, and that's very easy to do. You can just go to this M here, right click, add multiple values, and here you can just put the values in. So 4, 5, 6, 8, 10, 12 if you want. Okay. And then you can choose it from a list. Let's say 10. And for the pitch you can do the same. Add multiple values. 0.5, 0.6, 0.8, 1, 1.25, 1.5. Now you can you should be able to do the same here, or maybe not because it's not updated yet. Probably need to instantiate this again in order for it to work. This is 1.5 actually. Okay, now like I said, you can use this to instantiate all around your part. But let's say you wanted to use it in a different part. What you do then? Well, you first need to save this to your local drive. So you save as UDF thread like this. Now you go to Insert, Knowledge Template, Saving Catalog. You then create a new catalog here. Call it Master Class Screw. Save it and click OK. And now you can go ahead and use it anywhere you want. So if you create a new part, you then create a cylinder here like that. You can then choose the catalog. You need to open your catalog. Masterclass Screw. Yeah, I had it in the wrong place. Open the catalog. Part design. Awesome thread design. Double click this. Create your awesome thread. And that's it. Easiest buy. So if you enjoyed this video, I hope you find it useful. Please like and subscribe, share my video, and I'll see you next time.